Let's take a look at the physics of scuba diving. Most people are aware of the basic idea of scuba diving. You wear an air tank on your back, you breathe from that tank, and that lets you swim underwater. But let's dive a little deeper into the concept. First, let's talk about the air tank, because that's what makes it all possible. Now, I could talk about PSI or tank volumes, but let's keep it simple. I'm just going to focus on two things: how much air you breathe and how deep you are. Let's take a look at a diver on the surface of the ocean, and they're breathing from the tank. When they take a breath, they use up a certain amount of air from the tank, probably about half a liter or so, but that's not important. Let's just call it one chunk of air. A tiny amount of the total tank, really, but let's just call it a chunk. For a breath to feel natural and easy, the air pressure supplied to the diver's lungs must match the pressure outside their body. I'll come back to why this has to be true in a minute. So at the surface, we call this 1 atmosphere of pressure because the diver has one whole Earth atmosphere above them pushing down on them. Now let's take our diver down to 33 feet underwater, or 10 meters. This is the depth where the pressure is now doubled, so instead of 1 atmosphere of pressure, there are 2 atmospheres. That's because the pressure of 33 feet of water is equivalent to the pressure of all the miles of air in Earth's atmosphere. So at this new pressure of 2 atmospheres, one chunk of air is not enough to fill the diver's lungs. To fill the same space at double the pressure, they need double the air, so the diver needs 2 chunks of air. The same concept applies if the diver goes 33 feet or 10 meters deeper. Their body is now under 3 atmospheres of pressure, and now it will take 3 chunks of air to fill their lungs. As you can imagine, there is only a limited amount of air in the tank, so that means that the deeper the diver goes, the faster they will use their air. If, for example, they used up an entire tank in 90 minutes at the surface, that same tank would only last half as long at 2 atmospheres or 1/3 as long at 3 atmospheres. Okay, but why is that necessary? Why can't we just breathe a regular pressure air when we go deep underwater? Well, if the air pressure supplied to the lungs is less than the ambient pressure, then it will feel very difficult or impossible to get a breath. It's similar to the feeling of trying to suck a really thick smoothie or milkshake through a straw. This is because when we breathe normally, the pressure inside our lungs and outside our bodies is roughly the same, and the pressure forces cancel each other out. But if the outside pressure is much stronger than the inside, our breathing muscles have to strain to push outward to make up the difference, which is generally very difficult for humans to do. You could even make this an experiment. Find a long tube that you can breathe through and go swimming. You'll find that near the surface you can breathe through it easily, but go a few feet underwater and it gets very, very difficult. This is because you're trying to breathe in air that's at 1 atmosphere of pressure, but the pressure on the outside of your body is higher than that. By the way, disclaimer, I do not recommend trying this deeper than a few feet, as the sensation of having your chest compressed inward is very unpleasant and can cause some people to start gasping for air, and you could inhale some water, so don't do that. Okay, but back to diving. How does the scuba tank know what pressure to give your lungs? So remember, the tank is holding highly pressurized air, and if this pressure went right to your lungs, they would explode. The solution is to reduce the pressure in stages, using what we call regulators. The first stage regulator sits on top of the tank and reduces most of the pressure, and the second stage regulator is what fits in your mouth. This second stage has a clever design. It will take whatever pressure is pushing on it from the outside and then allow exactly that amount of air pressure to come out of the hose into your mouth. So no matter what depth you're at, all you have to do is breathe normally, and the regulator supplies the right pressure of air for it to feel natural. Anyway, stick around for part 2 where I talk about gases in your bloodstream, including how diving too deep makes you feel drunk, coming up too fast can kill you, and how oxygen can actually be toxic.